Hi student, in today's session we will discuss about crystal field splitting in tetrahedral field, which means the splitting of d orbital for those complexes which have the coordination number 4. For this purpose, we have taken a tetrahedral complex in a regular cube and the ligands are attached to the central metal ion and placed in alternate corner of the cube. And it is important to note that in tetrahedral complexes, 4 ligands are attached to the central metal ion, giving the coordination number 4. Now, the second point is the lobes of 3d orbital, which are dxy, dyz, and dxz, are in the direction of approaching ligand. Their lobes are completely in the direction of approaching ligand, as you see in the diagram, and as a result of which there will be maximum repulsion and their energy will increase by 0.4 delo, an increase in energy represented by positive sign. And the rest 2d orbital dx square minus y square and dz square orbital, their lobes are not in the direction of approaching ligand, so they feel minimum repulsion and their energy decreases by minus 0.6 delo. You can see that along z direction there is no ligands present. Along xy plane there is no ligands are present, as a result of which the energy of these orbital decreases by 0.6 del O, and the negative sign indicate that there is a decrease in the energy. And the last point, due to the difference in the energy of d orbitals, they are splitted into two sets of orbital known as T2 and E respectively. Now some important points I am summarizing over here. These orbital dxy, dyz and dxz are known as T2 orbital and their energy increases by plus 0.4 delo. Second point, dz square and dx square minus y square orbitals are represented by the symbol E and their energy decreases by minus 0.6 delo. The value of del T, which stands for crystal field splitting energy in tetrahedral field, is 4 by 9 of delo. And it is important to note that the value of del T always lower than del O, which means crystal field splitting energy in octahedral field will be maximum as compared to that of tetrahedral field, because in octahedral field there are 6 ligands causing maximum splitting and thereby the energy of del O get increases. Whereas in tetrahedral field 4 ligands are attached to the central metal ion and therefore the splitting is minimum. And the last point, which is very important, the pairing energy is always higher than del T, which means all the tetrahedral complexes are high spin complex and they form under the influence of weak ligand. All the tetrahedral complexes consist of weak ligand, and here we are showing the splitting of the d orbital in tetrahedral field. Let's see how it occurs. At first you can see that there are 5 d orbital and all the 5 d orbitals have equal energy, and this is known as degenerate d orbital or degenerate state. This is the condition when metal ion is not approaches by the ligand. This is free metal ion, and when the metal ion approaches by the ligand, then the d orbitals of the metal ion acquiring little bit higher energy than the previous one. And finally, it has been observed that some of the d orbitals are in the direction of approaching ligand, so their energy increases by plus 0.4 delo. The energy increases by plus 0.4 delo, and the some orbitals which are not in the direction of approaching ligand, they feel minimum repulsion and their energy decreases by minus 0.6 delo, and as a result of which the d orbital split into two sets of orbital E and T2. Each sets of orbital contain dz square and dx square minus y square orbital, and T2 contains dxy, dyz and dxz. And this is the energy order, how energy is increasing, that we are showing. And this dotted part represent no splitting zone. This dotted part is represented no splitting zone, which means the splitting of d orbital takes place above and below this line. Now, the next segment we will discuss about how the electrons are filled in the T2 and E sets of orbital for the tetrahedral complexes. So let's see how it occurs. Here I have already drawn the figure. Here we will talk about electronic arrangement of d electrons in tetrahedral field. In T2 there will be 3 orbital. For D1 configuration, at first we need to put electron in E set of orbital. For D2 like this, for D3 1, 2, 3, for D4 1, 2, 3, 4, for D5 1, 2, 3, 4, 5, for D6 1, 2, 3, 4, 5 and 6, for D7 1, 2, 3, 4, 5, 6, 7, for D8 1, 2, 3, 4, 5, 6, 7, 8, for D9 1, 2, 3, 4, 5, 6, 7, 8, 9, and for D10 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now write the electronic configuration E1 T2 0, E2 T2 0, E2 T2 1, E2 T2 2, E2 T2 3, E3 T2 3, E4 T2 3, E4 T2 4, T2 4, E4 T2 5 and finally E4 T2 6. So by the given way we can fill the electrons present in the d orbital of tetrahedral complexes under the influence of weak ligand, and these complexes are known as high spin complexes. These complexes are known as high spin complexes, means ligand's nature will be weak ligand. Hope you understand this particular session of the class. If you like this class, then you subscribe my channel and make comments more and more, so that I can work for all of you, and according to your question I will arrange my videos.